Okay? So I'm actually okay that you guys keep talking at the beginning, but under only one condition, that I take whatever minutes you take at the beginning at the end, right? So if we start 5 minutes late, I'm okay with that, but we finish 5 minutes late, right? So maybe we'll put this as a deal between us. Like whenever we start, like now we are 3 minutes delayed, so I'll finish 11:23, okay? Okay, so last time we discussed strings in C, and then we said strings are actually nothing other than arrays of characters, but with special handling, right? So just to remind you of the main intuition behind this, is basically you need a way to deal with strings. What is the reason for this? And this is something also good to know, is basically, so the thing is, you don't put anything in programming language to make it like a used case unless you have really a need in practice to do this, right? I said dealing with strings is actually needed in many applications, and I give you some examples like text recognition, machine learning, online translation. Like there are so many things, right? Authentication, these things. So we need to deal with strings a lot in our daily lives, right? So you need a way to handle strings in your programming language. Good? C then need to do something, but C doesn't have a type, like an inherent type, a data type that is called string. So what to do? Then we said you can deal with strings as arrays of characters. But there are differences between both, because if you just deal with strings as arrays of characters without any other support, then the problem is you need to handle everything yourself. Like all the rules of an array will apply to this string. For example, you cannot use the name of the array to do any operation, right? Basically you cannot, for example, concatenate two strings. Basically the basic features that you need to handle a string does not exist in a normal array, right? Concatenating, truncating, like so many other things, right? And we'll see some of these today. So I need an additional step. So the first step was to deal with strings as an array of characters. That's good, but it doesn't give you the full support. The second thing is the compiler gave us the chance, said, okay, if you define a string as an array of character, and this ends with like a null character, then I give you the support of deal with this as a string. For example, you can initialize it using only one word or like a text, right? We cannot do this for a normal array, right? Remember that we said, for example, to initialize an int array, basically, you need to do something like this. For example, you have to specify the elements, but you cannot do this. This is going to be considered only one number, which is element number 0, right? But then, in strings, you can actually do this. And enter your array as one entity, right? We have seen this yesterday. This is a different way of dealing with an array. In normal arrays, this is not actually allowed, right? But in strings, it's allowed. The other thing that's actually even more advanced than this is now you can deal with this full entity as one thing. One thing. Like arrays are actually number of elements, distinct elements. They have to be of the same type. They are placed contiguously in the memory, but they are distinct elements. You can add an element to an element. You can subtract an element to an element, but you cannot take all the elements of an array, integer array, for example, and do a math operation on these. You have to go through a loop and do it one by one. In strings, which are arrays of characters, you can actually deal with this as one entity and add it to another string, search this, as we have seen yesterday, do many other things as just one string. And this is the second advanced thing of supporting strings in C. It's basically dealing with the full array as one entity, which is not originally supported in normal arrays. Good? Okay. So this will be confusing, I guess. So as part of this support, yesterday we covered the support of not using the C library functions, but dealing with array of characters and do the things ourselves. But I said in C, there are some support to deal with strings. Some of these things actually to check for a certain type yourself, right? So we have a header file similar to studio.h, it's called ctype.h, and then it takes as an input something, right? And actually checks for the type of this thing, right? So for example, it takes a character or basically now it's a digit, it's a general thing that we don't know the type yet, and we check whether this is digit or not, or is alphabetic or not, is lower or uppercase, right? Why I would need to do that? I gave you the example yesterday. If you are entering a password to a website, and then you have to start with a letter, for example, you cannot start with a digit, then you have to check this yourself, right? So this is, so basically, assume I don't have this support. What can I do to check it? Can you think of a solution? Someone is entering a password. You need to check if the first entered character is a letter, not a digit. Yeah. Yeah. And then basically search, yeah, you can use the ASCII code and go through you know, from the table that alphabetics, like basically A to Z starts from a specific, now I don't remember the one right now, it's 26 or 46, something of that sort. And then they are actually ordered. So from E to Z, they are just one chunk. So you can check if the value of this character is between this and this, which is the value of A and Z. And then you have to do this for both capital letters and small letters, right? And if they are within this range, then it's actually a letter, right? Other than this, maybe you check for a digit as well or a special character. Because also some passwords will prevent you from using special characters or entering a username, for example, right? So you can do these kind of things by the hand of using the ASCII code. But you don't need to implement this yourself if you can use the C type. One important notice here is actually you have to pay attention in labs to what you are allowed to do or use and what you are not allowed to use. Because some questions will tell you you are allowed to use the math library, for example, or you are allowed to use only input and output, or you are allowed to use whatever you would like to use, right? So pay attention to the constraint of the problem, right? Because there may be a very easy solution. We know that it exists, but we want you to think of what if you don't have this support. Can you implement it yourself? Right? Okay. So there are so many examples of this thing, but we don't have the time to go through. Yeah. Yeah, basically because you don't know the type. We don't know what is C, right? So the way this is implemented in the C type header file, it takes this as a character, but it's okay. It will take anything. But why it's specially int, not a character, for example, because we said any character of the ASCII code has actually an integer value. So what it reads in reality is actually what is the ASCII value of this C thing. This is why it's int. Yeah, we said by default, you remember when we had this example of printing out A as a character and A as an integer, and then it was okay to use it as an integer, the casting will happen automatically, right? So it doesn't need even to convert. It will just read the ASCII value. Okay? Thank you. Okay. So we also have the string handling library in C. This is using string.h or cstring.h. And then this has so many other more advanced things, like concatenating a string or comparing two strings together. Usually this is called string matching, right? This is a very famous problem in reality that you want to match two different things, two different large strings. And in machine learning, there are so many ways to do this. So string handling library like cstring.h will allow you actually to do a string match or string comparing. And also you can use str_length to determine the length of the string. You remember yesterday we discussed the size and the string, right? This is somehow similar to size of. And then you can also use some support to search the string yourself. Yesterday we had the example of we are looking for a specific occurrence of the letter M, capital or small, and we count this. So you can use the internal support to actually search for a certain character. But even more than this, you can search for a string inside a string. So it's not necessarily to be a character. Right? Assume, for example, you are searching for a certain word in one page. Right? You can use this because one page will be a big string, and then we are looking for a substring of that string. Good? In the lab, you will cover some of these things. Good. The last thing I want to discuss before we move to another topic is actually we have also two other functions that are needed for strings. You know Scanf and Printf. We have used this to actually read and write from the screen, deal with the user, like we have a user interaction, right? Good. We have like two versions of these functions. It's called scanf, string scanf, and sprintf, string printf, that basically take something, put it in a string, or the other way around. Basically take a string and put it in another variable. What does that mean? Think of just normal printf and scanf. You read something from the screen, you place it in a variable, right? Using scanf. Or you take a certain variable and write it to the screen. You can think of the screen now as your array of characters or string. Good? Later we will see if you want to deal, like if you did the bonus question in lab 1, there are also a third version of things. Sometimes you may need to read or write from the screen, which is the basic thing and we covered. Sometimes you need to do this in just a normal string. And the third thing is read or write from files, right? And this was the bonus question in lab 1. So there are also other versions that actually you need to read or write from files. Process files, like look into a database, for example, or look into your records to check for a certain thing. Good? So one example here is scanf, my array, character, and then this variable thing. Then what you are doing is reading into this variable. So you read from my array, you scan the array basically, which is the string. You take one character and place this in the variable. And then sprintf, as you see, it's exactly the same order of parameters, but it's the complete opposite thing. You actually take the variable itself and place this in the first character of the array. So this here is your input, this is your output, this here is your output, this is your input. So in order not to be confused, think of the string as your screen, because this is the thing that you know well, right? Scanf is writing to the screen, and printf is reading, printf is writing to the screen, scanf is reading from the screen. Scanf is reading from the array, and sprintf, the array or the string, sprintf is writing to the string or the array. Good? Okay. Is there any question?